Okay, we have a magnetic forces question. Okay, as usual, take a look and then we'll see if we can help with understanding what the answer is. Okay, so we've got our loop of wire. It's in a magnetic field that is directed into the plane of the page. Now that's important because that means your first finger, which is showing the field, if you're using Fleming's left-hand rule, which I hope you are, first finger should be pointing away from you towards the screen right now. Now we want to think about what's the direction of the force on this thing. It's going to do a few things. It could rotate the loop, or it could reduce or increase the radius. That's our choices here. Well, let's think about it at this stage. If we were to think about our current at the top and then at the bottom of this circle, you can see at the top it's moving to the right and the bottom is moving to the left. The field stays the same. So if I'm doing my left-hand rule, currently I'm pointing with my first finger towards the screen, okay, and my middle finger is pointing to the right. My thumb is pointing up. Now what I want you to do is try and convince yourself that if we go down to the bottom, the first finger is going to stay in its right direction. However, the second finger is going to rotate by 180 degrees, as is the thumb. So hopefully what you're finding is that we are going to get a direction down. Now that is going to apply all around the circle. Notice that our force is applying at right angles away from the circle. And so what does that do to it? Well, it tends to increase the radius of the loop. It tends to make the radius get bigger because the force is acting in the radial direction out away from the center.